Greetings, mathematicians. We have learning target 21, box and whisker, stem and leaf, and scatter plots. Our essential question: how can I analyze data, make predictions, and answer questions based on measures of central tendency, scatter plots, and box and whisker plots? So just some vocabulary just to review. We have the mean, which is just the average. So you take all your data points, add them together, and then divide by the total number of data points that you have. We have the median, which is the middle number, making sure to be ordered from least to greatest. If there's an even number of data points, find the average of the two in the middle. We have the mode, which is the data point that occurs the most often. And we have the range, which is the largest data value, and we're subtracting the smallest data value from that. So box and whisker, it is a way to organize data into 4 groups or quarters, right? So each quarter contains 25% of the data set. So we see from the minimum from the Q1, that's 25%, from the Q1 to the median, also 25, so on and so forth. So here is our 5-number summary. You can see at the very left we have the minimum, then we have the Q1, median, Q3, and then the maximum. And this is just the definition of each, right? So the minimum is just the smallest data value. Q1, that's the median of the lower half. We have the median, which is the middle value. Q3 is the median of the upper half. We have the maximum, which is the largest data value. And then we're going to see this term as well, interquartile range. That is the difference between your Q3 and your Q1. So how do we create that? We want to order our data from least to greatest. We want to find out what is the minimum and maximum values. We want to find out what's the median. Find your lower and upper quartiles. Plot those 5 numbers on a number line. And then finally draw the box, the whiskers, and a line segment through the median. So here's our example 1. We have this data set. So the first step that we need to do is order the data from least to greatest. Then you're going to find the minimum and the maximum values. You're going to find the median. You're going to find the lower and upper quartiles. You're plotting those 5 numbers on a number line, and then we're connecting. So we need to go through and we need to find out what is the smallest number that I have here. Okay? So the smallest number that I see is 264, right? So we can go ahead and write that number out. So we're going to go write out 264. And I like to cross out as I go, right? So then again, I'm looking for what's the next smallest number that I see. The next smallest number that I see is 360. Okay? Cross out as you go. The next smallest number is 380. Okay? And we're going to continue that line of thinking all the way until we get to the very end. Right? So once we have that those numbers ordered from least to greatest, we can go ahead and we see that here is that list from least to greatest. Okay? So identify your minimum, which is at 264, the median, right, and the max. So we can see the minimum is at 264, the maximum is at 572. We have an odd number of data points, so the median is at 407, okay? And then we need to find out what's the median of that lower half, okay? So since we have an odd number of data points, we're going to exclude that median from our lower and upper half, right? So to find the Q1, we need to take the median of that lower half, right? So we take 360, 380, add them together, divide by 2. So our Q1 is at 370. Same thing with that upper half, right? We need to find out what's the median here. So that median is 459. Okay, so here's our 5-number summary, right? So we can go ahead and create that number line. If I'm doing it from scratch, right, we have that number line. So we're going to plot our numbers. So we have 264, which is probably right there. We have our 572 as our maximum, which is over here. We have our median, which is 407. Q1 is 370. And our Q3 is 459. Okay? So here is the box, here are the whiskers, and that's how we construct that box and whisker. Let's see how well I did compared to the computer animation. So it looks pretty good so far, and then there we have that box and whisker. And then to calculate the range, right, so take your maximum, subtract off the minimum. So the range is 308, and the IQR, the interquartile range, we take the Q3 minus the Q1, and we get 89. All right, so example 2. A data set contains student test scores. We know the median is 75 points. The third quartile is 85 points, and the range is 40 points. Which statement about the test scores in the data set is most likely to be true? A, the lowest test score is 45 points. B, the highest test score is 95 points. C, about 25% of the test scores are less than 55 points. Or D, about 25% of the test scores are between 75 and 85 points. Okay, so these types of problems, the easiest way to approach it is to create that box and whisker, label the things that you know, and then go through the options to find the one that has to be true. So I'm going to go ahead and create that box and whisker. It doesn't really matter what exactly it looks like. We just care about labeling the things that we know. So that first bullet point, the median is 75 points. So I'm placing that 75 right here. We also know the third quartile is 85 points. So that goes right here. And we know that the range is 40 points. So the range, right, the distance from my minimum to my maximum is at 40 points. Okay? I'm going to go through each option. We're going to see which one has to be true. So is it A, the lowest test score is 45 points? So let's go ahead and fill that in. Let's see what happens. So if I assume this is 45 points, so I know that the range is 40. So it could work, it could be a possibility. Not necessarily it has to be true because instead of 45, this could be 50, right? And the numbers could still work out. So I'm going to leave that open just in case if I did make a mistake. So we're going to go ahead and get rid of that. We're not sure about that one. Option B, the highest test score is 95 points. So again, if I pencil in that 95, kind of the same line of thinking. It could be 95. It works out, but not necessarily, right? So the highest test score could be 100, and the numbers could still work out. So again, I'm going to leave that as is. I'm not going to exit out, but I'm not going to commit to it either. Option C, about 25% of the test scores are less than 55 points. Looking at this, I don't see 55 in there at all, so I don't feel confident about that answer at all. And then option D, about 25% of the test scores are between 75 and 85 points. So I see this 75 right here, I see this 85 right here, and remembering the definition of box and whisker, it has to be that 25%. I feel very confident about that answer right there, so we're going to go ahead and select option D as the answer. And last one, Isabella participated in a quiz competition that had a total of 148 participants. Isabella's score in the competition was equal to the third quartile of all the scores. Nobody else in the competition had the same score that Isabella had. How many people in the competition had a higher score than Isabella? So same thing, we're going to go ahead and create that box and whisker. Isabella is a great test taker, so she is in that third quartile, right? So we know that Isabella is here. Okay. We know there's 148 participants in total, so n is equal to 148. We also know the definition of box and whisker. Each section is 25% of the data, right? So to figure out how many students are in each section, I can take that 148 and I can multiply it by 25%. That's the same thing as dividing by 4. So 148, right? If I divide that by 4, you can use a calculator to see that each section contains 37 students, right? So we know that this section contains 37, this also contains 37, and 37. So how many students, or I'm sorry, how many people had a higher score than Isabella? we see that 37 students had that higher score, meaning that our answer has to be option A.